Hello and welcome back. In today's lecture, I'm going to tell you about how to preserve values on the stack. Why is it important to preserve values on the stack? Take for example this script which we did in the previous lessons, where we wrote a script that will give you invincibility. So this is the script here, and if you have lost this or you don't have this, remember we save this as cheat table number 4. I will provide this in a download link for you if you don't have it. Okay, so in this case here, we make use of a temporary register called RAX in order to do some calculation on offsets. But there is a danger for this. Sometimes the RAX value contains some other data which is important, and if you were to make use of it now, you will modify those original data, and that might cause your program or your game to crash. Alright, so before we make use of any registers to do our calculation, we must first preserve those values on the stack and put them back later when we are finished with the calculation. So to understand how we can use the stack as a temporary storage for preserving data, I have created some slides for you using the stack to preserve data. So take for example, we have a register RAX which has got a value 2. And now we want to inject some code which will move 3 into RAX. But if you just go ahead and did this, it will destroy the value 2 in here. So in order to preserve the data in 2 here, we can put it on a stack. So a stack is a region of memory which stores some temporary data that you might use, or some instructions that you want to store temporarily. So we can push 2 to the stack by using this instruction called push RAX. Push RAX will push 2 onto the stack like this, so it will put on top. And then now we can go ahead and perform our move instruction. So move instruction will move 3 to RAX. Then when we are finished with whatever we want to do with the RAX register, we can now restore the original value back to the RAX by calling this instruction pop RAX. So pop RAX will pop whatever is on top of the stack back into RAX. So RAX is the destination. It can be pop RBX, pop RCX, but if you put pop RAX, it means that you want to take whatever is on top of the stack and put it back into the RAX register. That is the meaning of pop RAX. So now RAX will contain the original data that was originally there. Now take another more complicated example. If you have registers RAX, RBX, and RCX with 3 values like this, the value A, assume these are in hexadecimal in RAX, B in RBX, and C in RCX. And you want to inject some code which does these instructions. You are going to move 3 into RX, 4 in RBX, and 5 into RCX. Now if you just went ahead and did this, you will move 3 into here and destroy this data A. And if you move 4 into RBX, you will move 4 in here and destroy what was in RBX, and the same with RCX. If you move 5 into RCX, you will destroy this value C, and that might cause your program to crash later on if the program needed to use those values in these registers. So before we move 3 to RX, we should push RX. That means we save RX, whatever is in RX, push it on to the stack, save it here. Then we go ahead and do whatever we want. But let's say we also wanted to do something with the RBX register. right? So after we did this, now we wanted to do something in the RBX register. Before we did this, we should push RBX. So push RBX will push this on top of the stack. So now B sits on top of A. Then you perform move RBX, so we move 4 to RBX register. The next thing you wanted to do is to move 5 to RCX. But before you did that, you want to make sure you preserve what is originally in RCX. So you would push RCX. So push RCX will put this on top of the stack. And now you can do your move RCX. So you move 5 into RCX. Then you can go ahead and do calculations, whatever you wanted to do. Whenever you're finished with your calculations using RX, RBX, and RCX, and you wanted to go back to the original code, you can just do the reverse. So when you are doing the reverse, the order in which you pop is important. Because C is on top of the stack, you should not pop RX first. Because if you pop RX, you will take C and put it in RX. And you remember that RX originally had the value A, not C. Therefore, when you are popping, you should pop in reverse. Reverse order from that when you pushed. So, you should push RCX first, because push RCX was the last one which you push onto the stack. So when you are unwinding the stack, you should do it in reverse order. Pop RCX first, so that RCX will come into here. RCX will come here. Next, you should pop RBX, because RBX was the second. So, pop RBX. RBX, B will come back in here. Okay, 4 will go away. And finally, it will pop RAX. So when you pop RAX, you will put value A back into RAX. So this is a proper way in which you can use the stack. Now another thing, what about flags? Same thing with flags. So flags also has got flag registers. For example, you have 0 flag, carry flag, sign flag, and many more. But for simplicity, let's just say we are having 2 flags, ZF and CF flag. So whenever you do a comparison, for example CMP, let's say you're comparing RX with 3, the flags will be affected by this instruction. If the value in RX is 3, then the destination is equal to source. RX is destination, 3 is source. So if the destination is equal to source, 0 flag will be 1. Because you are taking 3 minus 3. When you're doing a comparison, it is like subtracting. You're taking RX minus 3. So it is 0. Therefore, you set 0 flag. 0 flag becomes 1. See, so when destination is equal to source, 0 flag becomes 1. Then, this jump will happen because 0 flag is 1. JE means jump is if equals. Equals to what? Equals to 0 flag 1. That is the meaning of jump equals. It also means jump if RX is equals to 3. So there are 2 ways in which you can interpret JE. So all the jump instructions are dependent on the flags here. So if the destination flags is less than the 0 flag, that means if RX is smaller than 3, then your 0 flag will be 0, but your carry flag will be 1. On the other hand, if your destination flag is bigger than source flag, which means if RX is bigger than 3, then your 0 flag will be 0 and your carry flag will also be 0. So this is how the flags have been affected by the comparison instruction. Why is that important? Take a look at this example here. Over here, before you use the RAX register or do any comparison, you must first preserve the registers. Because if you don't, and you went ahead to do your move and you do your comparison, you are affecting the register. And when you affect the register that way, and you come back to the code after your injection, your program might crash. Okay? So we want to preserve the registers and the flag. So how do you preserve the registers and the flag? Now for the registers, I already explained how you preserve it. How about the flags? For the flags, you can preserve whatever is in the flag registers by using a push F instruction. So before you do a comparison, you always push F. That means whatever is in the zero flag or carry flag or sign flag or whatever flag, when you do a push F, you are saving this in the register on top of the stack. Then you can do your comparison. So when in this case, if your comparison RAX is equals to 3, you will then set the zero flag to 1. You see? And then when you finish your comparison and doing whatever you wanted to do in the injected code, then you will do a pop F. A pop F will then take whatever is on top of the stack and then put it back into the flags register. So that is the meaning of push F and pop F. So this is how you can preserve the registers and the flag. So in our example here, if we wanted to preserve the register and the flag, before we move anything into RAX, what should we do? We should push RAX and then do whatever we want to do with RAX. And then when we finish with doing whatever we want to do with RAX, what must we do? We must pop back RAX. Put back whatever was in RAX into RAX register. Okay, the same thing with the comparison. Before we do any kind of comparison, here, before we compare, we must preserve the flags. So in this case, we will push F. That means push whatever was in the zero flag, carry flag, and sign flag onto the stack. And then when we are finished with the comparison, we should pop back whatever is in the stack back onto the sign flag. Alright? Now in this case here, we cannot put a pop F here because this jump here, it will depend on the zero flag. If you pop back the zero flag, then this jump will not happen because it will not be based on the comparison. So we cannot put a pop here. So in order to make this work, we have to modify the code a bit. So to do that, we have to create a new label called player over here. And then down here, we will put the player code. Okay, so when the instruction came to this line and it compares RX with 0, if RX is indeed 0, then you don't pop here. You also do not pop here. This test will be true, so it will jump. So in this case, we want to jump to the player code. So it will jump to the player code. So it is in the player code that you will pop F followed by pop A. Alright, now we're taking care of the player path. What about the enemy path? The enemy path will come here. You will push RX in the same way. You will push RX in the same way. And you also push F. Then you will do your comparison. And if the comparison yields that RX is not equal to 0, this will not happen. It will come here and jump to this code. So when you jump to this code, it means you are enemy. So when you're enemy, you should also repeat these two things. Pop F and also pop A, like that. So this is the save code. So using this code, you can be sure that you will not corrupt the register or the flags. Okay, so you can use the same principle whenever you are writing code, injecting code for any game that you are hacking, right? It doesn't have to be RNX. If you're using RBX or RCX or whatever registers, always push it first and pop it later when you're done with it. Same with the flags. If you are going to do any kind of inject any kind of instruction code which requires a comparison, then be sure to push F first and pop F later when you're done with it. Okay, so that is all for this lesson. That's all I want to say. So you can click OK, and you can save this now as a new version or 4, right? Maybe you can call this 4B or something. Okay, so I will call it 4B. Save. Alright, and I will put this code for you to download as well as these slides for you to download. So that's all for this lesson. Thank you for watching.